And in this video, we're gonna learn how to read a manometer and what to do if there's multiple fluids in the manometer, besides just your measuring fluid. So let's say we'll say that without any pressure differential, that this is the level of the liquid water that's in the manometer. Got a pressure up here, pressure 1, I'll call this pressure 2 over here. And there's pressure 1 is higher than pressure 2. And if this were all there was to it, I could just go figure out what the difference in level here is and get right to my pressure. In fact, what you're always going to want to do is start right here at the lowest level of your working fluid in the manometer. Draw a line over here and then measure this distance. That's going to tell you. There's lots of other ways to do it. You could compare it to this equilibrium line, but that's not the easiest way. This is the easiest way to say where's the lowest level and then measure it up to the highest level. And that might require that you measure from this line down. There might be indicators on the manometer that you have to read both of them. You might have to read here and then add them together. Okay, so we're going to complicate this one by saying that in addition to water in here, we've had a problem. And now we have oil sitting on top of the liquid on this side. But the oil, because it's oil, it's less dense than water. And it has what's called a specific gravity. And specific gravity means how dense is it compared to water. It has a specific gravity of 1, has the same density as water. It has specific gravity of less than 1, it's lighter than water, and it's going to, if it doesn't mix with it, it's going to float on the top. So oil, for this example, we'll say has specific gravity 0.7. Mercury has very high specific gravity, 13.6. All right, so how do we find out what the pressure differential is? What is delta P? It's going to be equal to P1 minus P2. How do we figure that out? So we know what's going to happen is that we just got to think through the problem. Got the gas is pushing down here, and we've got another pressure down here. We know pressure 1 is bigger than pressure 2. Pressure 1 is enough bigger than pressure 2 that it can raise up this liquid by that height. So we're just going to add them all together. We're going to say that the pressure is going to be equal to 1. This is water, so I'm going to just say 1 times H1. If I didn't have the oil, that's what the pressure differential would be. 1 times the height of the water column there. And just a little trick with algebra stuff. When you put a number in this location, it's usually doing something mathematical, so whatever term that is, maybe it's squaring or rooting it or something. But whenever I put a subscript down here, like 1 or 2 or A or B, that's part of a naming convention. This almost always holds true. That's just providing a detail about the name. So I don't want to confuse. I might always want to use H to indicate height. And which height is it? Well, it's the first one. And I might want to have another height here. We'll call it H2. So back to our pressure. Pressure is going to be this pressure plus 0.7 H2. That's really pretty straightforward. So now I just need to know H1 and H2, and I'm done. And that's what the pressure gauge right here would be. All right. So the reason I'm going over these problems is last year's class, when they did the homework, had some trouble with this. They didn't. It was hard for them to figure out how to add and subtract these different pressures when they have different liquids in them and out. Okay, so let's do one more.